Hi everyone. I just want to spend a few minutes today discussing how to produce a scatter plot graph. So in science class we collect a lot of data, and very often we want to look for relationships between the variables, or sometimes we call it a correlation. So the best way to do this is by comparing the data points and seeing if there is a relationship between them by producing a scatter plot graph. So I will show you how to produce a scatter plot and how to interpret what that line of best fit looks like and what we actually can infer based upon that information. Here's a simple data set that we can use to show how to produce a scatter plot graph. So it's looking at the effects of fertilizer on bean production. So a very simple made up data set. But if we look at the first column, their x-axis, which is our independent variable, is the amount of fertilizer in milliliters. The B column, which is our dependent variable, is the number of beans produced on this plant. So again, I just made up this data to show you how to produce a scatter plot graph. So the best way to do this is to highlight your column headings, and this will help when the graph is assembled by Google Sheets, and it will actually put those labels on your X and Y axes. So again, important to have your independent variable in column A, your dependent variable in column B. And so when I go to make a graph, there's a couple ways you can do this. You can click on this shortcut, Insert Chart, or you can go up to the Insert menu and find the Chart feature. Either way, it's going to go through and it's going to pick the correct graph for you most of the time. So I know that I wanted a scatter plot, so it is plotting all of these points on a graph. It takes the amount of fertilizer and puts it on the x-axis, which is my independent variable, and that's where this should be located. My dependent variable, the number of beans produced, is plotted on the y-axis, which is where it should be located. If for some reason your labels are not appropriate for your graph, you can simply change them by customizing your graph over here. So this is my scatter plot. I put my title in. I would probably want to change the title to be a little bit more specific to the purpose of my lab. But for this example, I want to show us how to get a linear trend line on my data set. So the way you're going to do this is by choosing the customize option in the chart editor. And from here, you're going to select the series. And if you scroll down, the left axis is going to be the default option, and we want to add a trend line. So if I click on it, what it does, it finds the best fit line and it adds a linear fit trend line for my data. There might be some instances down the road where we might not want a linear trend line, so we can pick different types of lines that might best fit our data. But for this example, we're going to see if there's a relationship between the amount of fertilizer and the number of beans produced. And this trend line just kind of makes this nice straight linear fit line. So it tells me something. I can definitely see there is a relationship, but how strong is the relationship? Well, we can use what's called the R-square value. This is the correlation coefficient. Actually, this is called the correlation determination, and it gives us a value. The R-squared value in this example is 0.979. 0.979 tells us something about the strength of that relationship. So what we need to do is we need to use this information to help us determine what type of relationship and the strength of the relationship that exists between the amount of fertilizer. Since my line is sloping positive, we know that this is a positive relationship. So as the amount of fertilizer increases, so will the number of beans. And since this number is 0.979, the 0.979 value tells us much about the strength of that relationship. So what we can see is when we have a positive slope, if the relationship value, the R value, is between 1 and 0.7, we can say it has a strong direct relationship. So Google will give you the R-square value, which is a correlation determination. So to get your R value, you simply have to take the square root of R squared to get your value. If a value is between 0.69 and positive 0.3, we call it a moderate direct relationship. So again, this is just a nice way to describe the strength of the relationship that exists between the variables. If the slope is negative, then we have an indirect relationship. So as you can see in the data table below, it indicates that when there is a relationship that's negative because your slope is sloping from the top left down to the bottom right, we can indicate that it's an indirect relationship. So in this example, as auto value of a car increases, we also see that there's the mileage decreases. So it's indirect. So cars that have very high mileage are valued less. So that's an indirect relationship. So correlation allows us to look for not only the type of relationship that exists, but the strength of that relationship based upon that correlation coefficient. So you're going to be asked to use this information very often when we are doing lab work, and you should be able to apply it to large data sets and to look for trend lines within a data set, just like we did here with this simple example. Thank you very much, and we'll talk soon.